This is a lesson for Algebra 1, Day 10, Simplifying Radicals. The objective for this lesson is students will simplify numerical radical expressions. We'll also look at algebraic expressions. So it's really important that you know your exponents and the roots of the exponents are the backwards or the reverse of them. So you just should know these. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. Now, you could go up higher. I would recommend you go up to 25 times 25 so that you know all your perfect squares so that you could do your math homework more quickly. Because if you recognize numbers, you will go through your math homework much more quickly. So what's a radical expression? Well, a radical expression has this sign, and you're used to calling this a square root sign, but this is actually called the radical sign. And we call it a square root sign normally because most people don't go past the square root of anything. So the number in here, whenever you see an expression in here, it's called the radicand. And then there's a number here. So there's no number there right now, but when there's no number, we could assume that there's a 2 there. However, it could be 3, it could be 4, it could even be 34 for all we know. So it depends on what's listed there. But if there's nothing listed there, this number is going to be 2. And this number is also called the index. Okay? Continuing on here. So, removing perfect square factors. So, we'll look at number 1 first, number 2, 3, 4, 5, and 6. Number 1, we know that the answer, the square root of 25 is 5. But why is it 5? Okay? The reason why is that we have to first look at this number and find its index. We know that the index is 2. Okay? So, what that means is that we need 2 of the same number to be multiplied with itself to be able to come out of the radical. So, we first factor the 25. And a good way to do it is just use the prime factorization of 25, which is 5 times 5. Okay, 5 times 5 is 25, so we factor out 25 as 5 times 5. We know it's the second root. Now, I teach this a little bit differently. I say that this is a prison. The radical sign is a prison, and a pair of prison buddies wants to get out. We look at the index. The index reveals in what size the groups need to come out. The groups need to come out in pairs. So we know that these 2 5s can come out because there's a pair of, they need a pair because the index is 2. So 2 of them try to escape. Only one makes it out, but the other one doesn't make it out and actually gets shot by the guards. So since there's no one left inside the prison is gone, and so the answer is 5. I share the story not to traumatize any of my students, but so that you remember how it works. So that's how the square root works. But if, for instance, let's say the index was 3 or 4, you would have to group them up in groups of 3 or 4. Example 2, 121. Again, our index is 2. Factor out 121. We know that 121 is equal to 11 times 11 with a root of 2. Index is 2, so we need to group them up in groups of 2. They try to escape. Only one makes it out, so 11 is your answer. Number 3, 256. Again, like I told you before, you need to factor out first. We know the factors of this could be 16 times 16. So that's the square root is 16 times 16. Group them up in groups of 2 because the index is 2, so your answer is 16 because one of the 16s doesn't make it out. Okay? Continuing on to number 4. Now number 4 is a little bit more tricky because it's not a perfect square root. Number 4 192 is the number that's the radicand, so we need to factor that. We know that 14 times 14 is 196, and that doesn't work. And we know that 13 times 13 is 169, and that doesn't work. So what we could do is factor it out. So we could just take 192, and we start factoring it. Whenever you have an even number, divide it by 2. So we know that 192 divided by 2 is 96. 2 is prime, so we circle a prime number. We don't want to deal with that anymore. 96 is 8 times 12. And we know that 8 becomes 4 times 2. And 12 is 3 times 4. And when we look at this, we already had a prime number here, and so we have another prime number here. And then we have a pair here. Now, pairs are important to look for because we're thinking ahead. Our index here is 2. So we have a couple of pairs of numbers, and we have a 3. It doesn't have a partner. So what we do is rewrite our radical expression, but with a factored radicand. So starting from the smallest numbers first, 2 times 2 times 3 times 4 times 4. Our index is 2, so we group numbers up in groups of 2. So the 2's have a pair, and there are a couple of 4's are being multiplied with each other. The 3 doesn't get to be paired up, so it won't make it out of the radical prison. Okay, so what ends up happening, the 2's try to come out. One of them makes it out, the other one doesn't. The 4 tries to come out. The other one doesn't make it out. And then the radical prison stays here as the square root of 3 because the 3 doesn't make it out. Now on the outside we have 2 times 4 is still left, so we want to simplify that. So 2 times 4 is 8, and it's rad 3 is the answer, 8 rad 3. Continuing on. Number 5, a little bit easier problem. So, and remember, you could pause the video before and try it by yourself and then see the explanation after. Step 1, find the root, it's 2. Step 2, factor out the 18. 2 is prime, 9 becomes 3 times 3. Circle the 3 and the 3. And we have the square root of 2 times 3 times 3. Circle the 2 3's, and our index is 2, so one of them makes it out, the other one doesn't, so it's going to be 3 rad 2. Okay, and I'm going to not put the index this time because I know that when there's no index, we automatically assume it's a 2. Last one, number 6, rad 50. Rad 50 is like, I'm going to do a side problem over here. So we have 50. And 50 is a special number because I'm thinking about my square roots now. I know 50 is like saying 2 times 25. And I know that 2 is prime, and 25 is a perfect square of 5 times 5, which are both prime. So I could even go as to say we could factor out 50 to be 2 times 5 times 5. Some students will just say 2 times 25, and they know that 25 is the perfect square of 5. So whatever method you want to look at, that's fine. Pair up the 5's, 5 comes out, rad 2. Okay? And that's how we simplify numerical expressions. Continuing on here. So example 2 is removing variable factors. So this is just like before, except you're dealing with some variables. So this is the algebraic expression, or algebraic radical expression. So focus on your coefficient first. Your coefficient, remember, is the number in front of the variable, which is 45. So take 45, do a side problem or side prime factorization problem. So 45 becomes 5 times 9. 5 is prime. 9 is a perfect square of 3 times 3. Okay? So we can continue on and rewrite the radical with 3 times 3 times 5. And then a to the 5th is like saying a times a times a times a times a. It's going to get ran out of space there. And we know our index is 2, so we do the same thing. We would pair up pairs of 3's and pairs of a's. Unfortunately, there's one 5 here and one a here that's not going to make it. So what you end up needing to do is you're going to leave those on the inside of your radical, so it'd be 3 is going to come out, one of the a's will come out, and of course their friends won't make it out, and then another one of the a's will make it out. And by the way, there's always multiplication signs between these. And then there's a radical 5a. Simplify the expression. We have 3a squared times 5a, or 3a squared rad 5a is your answer for the first one. Continuing on, example 2. Same type of thing. So in example 1, remember we have to factor out the coefficient first. So factor out the 27, so doing a side problem, or side factorization tree. We know that 27 is a perfect cube. It's like saying 3 times 3 times 3. And you'll get familiar with doing these as you do them more regularly. And then n squared is like saying n times n. Our root is 2, our index is 2, so we pair up our numbers in groups of 2. Groups of 2, cross out one of them, so one of the 3's will make it out. The last 3 doesn't make it out, and an n makes it out. Okay, but then we have a 3 that does not make it out, so it's going to be 3n rad 3 is your answer. Okay, continuing on here. Number 3. We got rad 60a to the 7th. Okay, so again, square root of 60. So we know that 60 is equal to 4 times 15. 4 is a perfect square, so it's going to be 2 times 2 times 15. And it's a to the 7th. Now here's a little trick. I'm going to leave a to the 7th there this time. So we want the square root of a to the 7th. So I know that there should be 3 pairs of 2 and then 1 left over 7. So what you could do is you divide 7 by 2. So working on this, here's a quick trick. You could do 7 divided by 2, which is going to be 3. Let me put that in a better place. 7 divided by 2, which is 3. And we subtract, we have a remainder of 1, which means there's going to be 3 groups of a. So there's going to be an a to the 3rd on the outside, and there will be 1 a left on the inside. Focusing on the numbers, we have a group of 2's that will come out. Only 1 makes it out. And then, of course, this 15 doesn't make it out, so we just get stuck back into the radical sign. So your answer is 2a cubed, rad 15a. Continuing on, multiplying radicals. Multiplying radicals is very easy. As long as the indexes are the same, you can multiply your radicals together. So, for example, on example 1, radical of 2, radical of 2, multiply them together. So it's like we could just put it under a big radical. Radical, square root of 8 times 12. Now, we could multiply this together, and we know that this is going to be equal to rad 96, but we want to simplify it, and we're going to factor it anyway, so what's the point of multiplying it? I think it's better just to factor each of these numbers separately. So we know that 8 is going to be factored to 2 times 2 times 2, and we know 12 is going to be factored to 3 times 2 times 2. Now, we look at our index as before, pair them up. We got a couple 2's here, and then we have a 2 here and a 2 here. Or actually a pair of 2's here we could just use, okay? This 2 and a 3 cannot pair up with any other the same number, so they don't make it out. So one of these 2's will make it out, the other one doesn't. And one of these 2's make it out, the other one doesn't. There's a multiply sign there. Square root of 2 times 3. So 2 times 2 is 4, and then rad 6. There you go. That's how we multiply radicals together. So continuing on, of course, we want to simplify radicals with division symbols. So radical, this one says this second root of 9 over 81. 2 ways to do this. First way is you could simplify the 9 over 81 first, or actually just go rad 9 over rad 81. And this is like saying, what's radical 9? It's really equal to 3. Radical 81 is equal to 9. Simplify, this is like saying 1/3. Or another way you could do this is you just simplify the fraction on the inside first. We know 9 over 81 is like saying 1 over 9. And we know that 1 over the radical 1 over 9, the square root of it is actually 1/3, because it's like saying 1/3 times 1/3. Pair 1/3s up and you get 1/3 as your answer. So this is how we would do simplifying radicals within radicals. Okay? And that's the end of the lesson.